Good morning and welcome back to the channel. It's always beautiful having you here. Today we are concluding our discussion on the INVIC battery of tests, and we are concluding by discussing the last type of test, which is the VP test. Remember, we've talked about the methyl red, indo red, and all of the different types of tests in the INVIC battery of tests. Now, the last test is our VP test, Voges-Proskes test, and this is a test that we also use. Is used as part of the INVIC batteries of tests to determine for to identify and differentiate microorganisms within the family Enterobacteriaceae. Now, when we're talking about methyl red test, we said that some of the bacteria are able to do what we call mixed acid fermentation, where they now ferment glucose, use up glucose for their respiration, ferment this glucose and give rise to a mixture of about 4 acids, succinic acid, four different acids like that, lactic acid, and 4 different acids, which we now use to identify them. That is what happens in the methyl red test. Now, the VP test is sort of like an inverse of the methyl red test, because here is testing the ability of bacteria to break down glucose into pyruvate, and then lastly into a compound which we call acetoin. Now, you see the difference being that if a bacteria is able to break down glucose into acetoin, that means that bacteria is not able to do mixed acid fermentation. And so it means that if an organism is methyl red positive, most likely that organism will be VP negative. And if it's VP positive, it will be methyl red negative. These tests are just looking at the different pathways through which different bacteria are able to break down glucose. So in the instance of your VP test, you are saying that the bacteria is able to break down the glucose, and it breaks down the glucose by breaking it from glucose to pyruvate, and from pyruvate to acetoin. Now, when it breaks it down to acetoin, this compound, we now find out that it can be hydrolyzed. It can be hydrolyzed into diacetyl. If we hydrolyze it into diacetyl, then we can test for the presence of that diacetyl using a set of reagents which we call the Barrett's reagent. There are 2 types. So there is Barrett A reagent and Barrett B reagent. The Barrett A reagent has 5% alpha naphthenol, and the Barrett B reagent has your 40% potassium hydroxide. These are 2 reagents that we add into our VP test to be able to test for the presence of diacetyl. And the presence of diacetyl is coming from the product acetoin, and acetoin is coming from what? The method in which the bacteria is able to break down its glucose. So you need to understand these reactions forward and backward so that you understand what is happening. And as usual, like I said in the instance of the methyl red test, we know that we produce a broth which we call methyl VP broth. So this broth is produced, and then we use it to run both the methyl red test and the VP test. So in this instance now, we are limiting ourselves to the VP test, that's the Voges-Proskes test. We are looking at all the different processes that happen in the VP test, and this is very, very important for us to know. Now, what's the procedure? Like I said, we're going to prepare our methyl red VP broth, and then when we've prepared this broth, we put a buffer, and then we incubate at 35 to 37 degrees centigrade for a period of 24 to 48 hours, and then we inoculate with our bacteria of interest, and then we add our Barrett's reagent A. We add 0.6 mils of Barrett reagent A, and we add 0.2 mils of Barrett reagent B. We shake gently to expose to oxygen, and then we allow for 15 to 30 minutes to observe a color change. Now, this is a simple procedure, and if we see the development of a red color in the mixture, we say that mixture is VP positive. So it means that it is Voges-Proskes positive, and that in essence tells you that the bacteria was able to break down the glucose into pyruvate, and then into acetone, and from acetone into diacetyl. That's what it tells you. And that then it also means that you're able to confirm that means that bacteria is unable to do mixed acid fermentation. These are the things that we need to know. And you have that red color, a red color indicates positivity. If you don't have any color change, or you have a color that looks like copper, then you can see that that is negative and the bacterium does not produce acetone. That means it's possible that the bacteria engages in mixed acid fermentation. Remember that I said from the beginning that all these tests, we're either going to test for the presence of an enzyme in the bacteria or the ability of the bacteria to break down glucose in a particular kind of way. So these are the tests that we do, and they are quite interesting for us to know. So the VP test is important. It helps us to differentiate. You can see there are many organisms. Escherichia coli, for an example, is methyl red positive, is VP negative. Enterobacter is methyl red negative, VP positive. Klebsiella is methyl red negative, VP positive. Salmonella is methyl red positive, VP negative. So that, like I said, it's an inverse of one another. So the VP test and methyl red test, you need to understand them, that they are like the flip of the same of the two sides of the same coin. So this is important for us to note, and that brings us to the end. We should also realize that there are some limitations for the VP test. It can be delayed. You can have a weak VP test reaction. You may need to shake very well to get the kind of reaction, and sometimes it gives false negatives, meaning that if you get a negative result, it may not really be negative, and that makes sometimes these tests are difficult to rely upon. And that's why the molecular methods of identifying microorganisms are the gold standard. They are the way to go. And we'll discuss many of that. We've discussed some of them. We'll discuss them even more. So thank you for listening to this. Remember to like our content. Remember to share our content, and to have a beautiful day.